Okay folks, I'm going to give a video lecture today on mechanical waves and the properties of mechanical waves. Um, so we'll first start out today by talking a little bit about periodic motion, motion that repeats at regular intervals. Let me start off just by giving or showing some examples of periodic motion. Here are two examples. Here's a mass on a spring that is oscillating up and down. Orbits around, like the moon orbiting the earth would be an example of periodic motion. It repeats itself in the same way at regular time intervals, even equal time intervals. This repeats itself. The motion repeats itself in regular intervals, equal intervals of time. Here's another example of periodic motion. It's a pendulum. The motion is the same, and it takes the same amount of time for the motion to occur over and over again. So a mass oscillating on a spring would also be periodic, like I said. The motion takes the same amount of time, and it's the same motion over and over again. The motion is periodic. Okay? So periodic motion. We'll need to understand periodic motion and periodicity to understand waves, because sometimes waves are periodic. So let's move on to waves. In general, waves are the movement of energy through matter. Okay? Mechanical waves are the movement of energy through matter. And it's important to remember that not only do they require, not only are they created by a disturbance to a medium, they require a material medium. You can't have a mechanical wave without some sort of material medium. All right? So they're the movement of energy through matter. The movement of energy through matter. We've talked about how matter can move, but waves are the movement of energy through matter, solid, liquids, and gases. Okay, and matter is just what we refer to as a medium. So let me show you. Here is a string made up of particles. Some are green, some are blue, or some are green, some are red. It doesn't matter the color. It's not important. But we have a series of particles that make up our string. And now I can cause a disturbance to the string. Right? And let me do it manually. I can cause a disturbance, and that disturbance will propagate or move through this medium, move through the string. So I can send one like this, like this. I can send a whole bunch. And that disturbance just propagates. That energy just moves through the medium. Let me slow it down so you can notice here that it is just the energy that's moving to the right here. If you look at the particles, they're just moving up and down. Let me do a big one. The particles just move up and down. Let's see if we can do a really slow one. There we go. So the energy moves to the right, and the particles go up and then down. Up, down. One more time. Watch this one. All it does is go up and then back down. It doesn't go anywhere horizontally. Okay? So waves are the movement of energy through matter. That's very important. Key concept. I've got it down right here. Waves transfer energy through a medium. Matter is not transported by a mechanical wave or any type of wave. All right, so a wave pulse. I just showed you a wave pulse. Let's talk about the difference between a wave pulse and a periodic wave. A wave pulse is a single disturbance that travels through a medium. So a wave pulse would just be a single disturbance traveling through that string. But if the source of my force, if it repeats at regular intervals, see, this force by this piston is periodic. It repeats and does the same motion every cycle. This is a periodic force that's disturbing the string. That also creates these periodic waves. It's a series of wave pulses that reoccur at regular intervals of time. Okay, so this is a wave pulse, a single wave pulse. And then you can also have a periodic wave, which is a series of wave pulses back to back at regular equal intervals of time. That's what makes this transverse wave periodic. wave speed, that's how quickly that the energy moves through the medium. And there's two ways to calculate that. One is what we learned in semester 1, how far it moves over a given amount of time. That would give you the velocity, but this is not a very practical thing to measure, because a lot of these waves, like the speed of sound for instance, goes over 300 meters per second, and it's very hard, human reaction time, and for other reasons, to measure things like the speed of sound using this. It would be much easier and practical to measure the speed of a wave by multiplying its frequency times its wavelength. And we're going to talk about frequency and wavelength. That is how you get the speed for a periodic wave. This doesn't work for wave pulses, so sometimes we have to revert to this for wave pulses. But this will work for periodic waves, and this is what we should use most of the time. Alright, and I want to talk a little bit about medium. I already talked about medium a little bit, but the medium is just matter. Any solidless liquid or gas can serve as a medium to carry a mechanical wave. So one we're all probably familiar with is air. Air is the material medium that carries sound waves through the air, okay? Your larynx vibrates and disturbs the air, compresses the air. And see, this could be like your compresses the air and sends those waves through the medium, okay? And that medium, this could be air molecules, and this could be your vocal cords vibrating and compressing the air, sending those pulses. And then over here, I could have it, my ear would be over here to pick those sounds up. All right, the Earth's crust is a medium for shock waves during an earthquake, so that's another example. And then when you drop a pebble in a pond, the waves that move outward, the water serves as the medium for those waves. I have an example of that. Check it out. The water droplet will disturb the medium, and that disturbance, the wave, the energy, will move outward in all directions. And then you actually see you get a second drop, which is going to cause a second series of pulses through here, which almost makes the wave periodic. Oh, look, we turned into 3 droplets. So we'll get 3 more ripples sent, 3 more waves sent out. So water is serving as the medium for these waves that go outward. Water is the medium for that one. Okay? That is your introduction to periodic motion and waves.